Good evening, all. So, good evening, Sura, Aishwarj, Udit, Ruchita, Danpal, Nishita, Pupul, Vasista, Ganesh, Vivek, Deep, Sumit, Sriram, Bharati, good evening. Rudraksh, Harsh, Sagar, Chutki, Chitik, Mohan, good evening. Sushil, good evening. Krunal, Rohit, Kanshu, Kumari, Akshat, Arun, Chaitanya, Rushikesh, Ritesh, Rahul, Abhinay, Mohan, Anuj, good evening. So, how are you all? I am very fine. I hope you enjoyed your weekend. I also enjoyed. Thank you, Sagar. I need to thank you all because of you, it is possible. Thank you, thank you. I dedicate this 1 million minutes to you only. Okay, this is for you all. पार्टी करेगा अभी तो पॉसिबल नहीं. We need to make so many parties. Thank you, Anuj. Thank you all. Thank you, Ganesh. So let's move. Sequential circuits, right? So today, already last lecture, we have covered everything about the sequential circuits except some problems. Now we see the problems based on this. Today class mostly we discuss problem. Maybe tomorrow and just give me 1 minute. It will start last 10 days. Just 1 minute. Let me check how many days I have. This week. Today is 13, right? No problem. Actually, tomorrow is not needed. Logic family is not needed. It is just 2 lectures. You can skip Surah. Networks mostly on August 3rd. Timings I will tell you. Okay, I have not finalized anything. Still we have some time. For ESC also it is not required on us. Logic families. Okay, sequential circuits. So please see today and tomorrow plan. I can do 2 things. You tell me. Today shall I start FSM? What is the meaning of FSM? Finite state machines. Tomorrow, okay, anyway, it is a doubt session. We do all problems of this chapter completely. One method. This is one method. Again, today is 13, right? 14 and 15. FSM complete, and then we start data converters. This is one method. Another method is today problems. AFSM. Okay, 15 also AFSM and data converters. So this is option A, this is option B, your option C is both or anything. So let's start with poll. Give your answer. Poll not visible. I'm writing here, see, if you want I can increase the time, just wait. 13 today FSM, 14 problems, 15 FSM, one method. 13 problems, 14, 15 FSM. Okay, this is option A, this is option B. C is anything. Okay, let me check. Option A is having more percentage right now. D is I don't mind about this class. So finally, A is the winner. Option A is winner today. Okay, option A is our winner. Winner takes everything. Nishita, if everyone is tired, why 57% have opted this one? Okay, they don't want to solve the problems. So, okay, they want to enjoy relaxedly. Yes, it is there, Anuj. So let's start. Okay, today I will give questions as your homework. Tomorrow in the class I will solve. Yes, winners take solves principle. You know that algorithm, Abhijit? Kumari, don't accept logic families. You have everything in your syllabus. I already told that in the first class. Good, Abhijit. So let's move for today's class. Very, very important. Finite state machines. Okay. This is important like anything. In EC paper, they included this in 2016. Just let me complete. Don't ask this any other question. Okay. 2 marks, 2 marks, 1 mark, 2 mark. I think 1 mark. I don't remember these two. I'm not sure. Every year they gave. For a double E 2020, they have given 2 marks, but they have not specified it in the syllabus. But they gave it in 2021 question from this part. Good evening, Lucky. So be careful. Be careful with this topic. Just 2 to 3 hours topic only. It is from the sequential circuits only. But this will, if you understand our class sufficient, you can solve any question. Yes, Aditya. If you understand, just follow our class. Nothing else is required. Because I made the notes when they introduced this in the GATE syllabus. I mean, 2016. Before that itself, I made the notes for this. Still, your questions, all questions, you will be able to answer from them. Okay. First, follow this class, Chaitanya. Then you can worry about all those things. You can see the schedule in my profile. There, wherever logic families is there, at that time you sleep happily. Chaitanya, for triple people. Okay. I will announce it whenever it is required. There is another good chapter is there, data converters. After that, at the end of that, I will tell you what to do. Don't worry after that. Thank you, Sushil. So let's move. I didn't prepare the slides for this. Actually, I thought of doing problems today. No problem. It doesn't matter. So now we are going to deal FSM. What is FSM? Finite state machines. Okay. In this, you have two type of finite state machines. It is a Mealy FSM and Moore FSM. Let me upload one figure such that I need not write it completely. Just 1 minute. Yeah. Which DPP? Any DPP you can ask tomorrow, no problem. That second DPP I have given that one. Yes, I can discuss tomorrow. Today also I will load you with a few questions. Don't worry. So Mealy state machine, and there are two types you can design this. Okay, these are the two different types of designs we can have. Okay, so listen here, please. Firstly, before going to this, let us understand what is the meaning of the state machine, or what is the need for this. Okay, stop that discussion. Let me please concentrate carefully. If you feel difficult in this, you will not able to understand. Please concentrate. Okay, so you have Mealy and Murray state machines. Before that, what is the meaning of the FSM? Okay, I told what is that? Finite state. Now, listen here. Let me give you an example. Suppose you are designing some software for the what is that, or some hardware circuit for washing machine. It is having different stages. So when it is at empty stage, you fill with cloths and water. Then from here to here, it will move to some, what it will do? Yeah, detergent. It will do washing, some soaking, whatever you call it will do it part. Then it will rinse. Then it will give your final output. That is washed clothes. Okay. Someone please answer him. Khan. Message me on an academy. Khan. I can help you. Don't worry. अनअकैडमी ऐप में एक बार मैसेज कर लीजिए, मैं हेल्प करेगा हाउ टू गेट ऑल दोस थिंग्स वी डिस्कस देयर. So now see here, you have a washing machine which is empty, so we fill with cloths. So frequent steps are going in this. Listen here. In this, by chance, suppose you have not filled any cloths. This is the input you are giving. If you filled it, it will give some output. When you message, just wait. Maybe after today's class or somewhere, I will check it. Daily, I will check at the night. Don't worry. I will check and give you reply. Don't worry. Now see here, clocks are filled. Then you have two kind of outputs. One is a green LED. One is a red LED. Okay. So green LED will tell you when clocks are filled. Okay. Not filled. It may give some alarm or some buzzer sound. Like that, you are designing some washing machine. Every time, when it is washing, some power is gone. Then it will give some alarm. to give some backup or to take the class or to wait like that. Every stage, based on the inputs you have applied, you can have some different next state. Suppose here power is gone, it cannot, after 45 minutes, it should go to this state. But because power is gone, it should wait here only. It should wait here only. It should not move to the further. This is general example I am taking and explaining you. So the need for this design. So now listen here. So this design will tell you like this is the design. For example, now what you do it as a designer, we should design the state machine like this. We should decide on how many number of states, like washing, soaking, rinsing, whatever maybe different states you are having. At each state, what are the inputs? What are the outputs? So based on the present state, your input will give you some output. You are in a one particular state. Based on your input and this state will decide what is the output and what is the next state. So first we design this. First, we one general problem is taken. We write all the different states possible in this. At each state, what are the inputs possible? What will be the output? What will be the next state? Everything we connect. Then it will give you one diagram called state diagram. From that, we start designing. First, simple, basic, generalized view. I have explained the meaning of the state diagram. Counter is one state. What a counter is counting number of clocks. Na 0 is one state. Next 1 is one state. 2 is one state. Simple example of state machine is a counter. This is the counter state diagram, for example. But in the counter, you don't have any separate input. For counter, what is your input? Clock. What is the output? Flip-flop output is your final output. So you can say, listen here. Counter is an example of a state machine with clock as input and flip-flop output as output. That is here state. There is no separate output bit in the counter. Q2, Q1, Q0. Your flip-flop bits are your output bits also there. Yes or no? In the counter, you don't have separate. In counter, you don't have separate output bit, separate input bit. You have only clock and flip-flop output. Okay. Is it lagging? क्या हुआ? Just wait. 1 minute. Don't worry. Okay. Some issues. Don't worry. Just wait 1 minute. I will change the connection. No problem. We can make the best. We have other alternatives. I hope I am audible. It may refresh again, don't worry. Now is it fine? Okay. I don't know. Okay. So let's continue. So count is an example of one state machine with clock as the input and flip-flop output as the final output. Okay. Now, in reality, we have two types of state machine designs. That is, when problem is given, you can solve it by two ways. One method I am showing you now, different ways. What is the basic difference? Let me show you first. These are the two different ways you can design Mealy and Moore. What is the basic difference between them, sir? Just listen carefully. Don't do anything, just wait. Okay. Is it lagging? Now, finally, it will refresh on its own. Once you connect to new network, it will refresh 2 times. So, okay. So, let's see here. Where we are. Yes. You have applied the input to the combinational circuit. Okay. Which will decide, this is a state register. We can say like a counter, some kind of circuit is there where you apply the clock. This is the sequential circuit. For the sequential circuit, okay, you are applying the input, some design is required to get the next state. Okay, and then based on your, please see here, your present state and input will decide the next state. Okay, this is what we call next state combinational logic. That is, your input and your present state will decide where to go. This is like a memory. Okay, state memory, you can say. It is simply, you can say sequential circuit, it is a state memory. Okay, you can also call this as input logic. Then this state and input will decide what is the output you need to get. Based on the state and the input you have applied, you will be getting the output. This is what we call Mealy design. There is another way to design it, is Moore design. In the Moore state machine, the design will be like this. Your input is applied based on the present state, and the input you get the next state logic or next state based on the flip-flop condition, and your state only defines the output. You observe what is the difference here? This line. Here your output depends on both input and also here your output depends on both input and also state. Here output depends only on the state. I will explain the differences again later, just for continuity. What is the advantage in this, sir? There is an advantage here. What is that? If your input is directly affecting the output, okay, so even your clock is not applied, some noise occurs here. That noise can affect this output here. Okay, it is not more immune to noise, but here what is the advantage? Even some noise occurs, as long as clock is not applied, you will not get anything here. As you don't get anything here, you will not get anything. Okay, so you can have better noise immunity in the second case compared to first case. Okay, so similarly here also, here its system can directly, input can directly affect the system, may suffer with metastability. Noise can be anything, it can be environmental noise, anything other than what you required, what is your desired. Suppose you give 0, you have not disturbed anything. Somehow because of power supply, something you got some ones, it is a noise. Noise is anything undesired. That is, other than you give, whatever comes, that is your noise source. Even this class will also be noise for computer science people, or suppose mechanical people is there. Okay, for them it is a noise because they don't want it. For electrical people, logic families topic is like a noise. It may not be noise for EC people, like that. So listen here. What is Mealy and Moore state machine? 1 minute, please. Okay. Okay, right. See here. You are here in the Mealy state machine. Output depends on present state and input. Here, output depends on present state only. Input cannot affect output directly. Input affects state, then who will affect the output? State affects the output. Up to this point, if it is clear, then we will enter into the original discussion. You can see this figure, same figure I write here. Very good, very good. So let me start now. Please concentrate. You will be able to do better. You can understand easily. Once you understand the logic, it is a very easy topic. You can score 2 marks easily. So now, firstly, I will start with Mealy design. Then I will explain more also. First, Mealy state machines. Okay, first we discuss the Mealy state machines. So here, let me take one example. Example in the sense, randomly, let me take one state diagram. So that from that I will give you the problem. I will give you the explanation. So let me take a state diagram. Say I am having 3 states, S0, S1, S2. Okay, I am having 3 states. Every state, this is just example. Don't ask me why this is like this. Why not you draw different way? Okay, this is example randomly taken. Another best example for state machine design is your lift. When you are in the lift, now you have 2 symbols. Okay, you should say whether you want to go down or you want to go up. You will press one symbol. Then wherever the lift is, it will suppose it is coming down. You also want to go down. Okay, already some fellow has pressed some ground button. Then it will stop here, take you and go. Suppose it is coming down, but you want to go up. Then what happens? The program should be written like that. When it is coming down, okay, it will check your input is up or down. If it is up, it will stop and it will not stop. It will continue because it will save the time. If it is down, then only it will take. Okay, so this like that every state will have 2 choices. Okay, when you get some input, whether you need to stop at that particular place or you should continue. Or if you are already at rest, that is depending on your present state, your input will decide the next state. Okay, like that. How many of you know this? For example, you are in the ground floor. Assume ground is the 0 level. Okay, or suppose see here, lift is at 4th floor. You are at 3rd floor. 4th floor. It is going to. Sorry, I will ask you just common sense. It is halted. Okay, so yeah, it can save energy, time, everything. Na? So lift is in fourth floor. It is in halt condition. Halt means stop. Okay, you are in the third floor. Okay, you have two buttons. You have two buttons. One is up, one is down. Okay, you want to go. Okay, you want to go to fifth floor. Don't comment anything. I will conduct a poll here. Okay, you press up or down. Okay, I will start the poll. Just tell your common sense answer. You might have used lift so much. I will prove at least 40% or some more percent maybe will give wrong answer here. Question is clear. Let me ask you first. Question is clear or not? You are in the shopping mall. Okay, 10 floors are there. 1 minute. You are in the shopping mall. You have 10 floors. In the 10 floors, lift is already at. It is easy. It is just okay. Any person who is going to mall should know this. Forget about our digital logic. Okay, lift already stopped or taking rest. Rest in the sense no one is there in the mall. I mean, it is already stopped in the fourth floor. It is not in the continuous motion. Okay, so it is now. This point is clear or not? Lift is in the fourth floor. It is rest, taking rest. Okay, now you are in the third floor. You finished your shopping. Okay, you want to go to fifth floor for you want to eat something. You want to go to fifth floor. Okay, so you have two buttons. You will press up or down. That is my question. Lift is in the fourth floor. So will you press up or down? You are in the third. So let's start. I told you 55% wrong answer there. C option भी है 4%. Okay, why do we upload this later poll now? You should press up, man. You should not say to lift, come down. You are in the third floor. If you press from here, automatically lift notes. It need to come down because it is third floor. Okay, that is signal is coming from third. For that, they need not give you two buttons. Okay, this is to avoid this thing. Suppose lift is going down. Okay, you want to go up. It should not stop at the third floor. Okay, please listen carefully. You have for if you have only one button, old lifts will have like this also. If you press, say lift is going to ground floor, at that you want to go fifth floor. Okay, at this time also it will come here, take you and go to down. It will waste your time, lift energy, everything will be waste. So you want to go fifth floor, you should say that I want to go up. So if it is going down, it will not take you. Okay, old building में ऐसा होता है ना earlier days. So it is going down. You can design this simple with your logic circuits. Okay, you will. It should not stop. So that's why you observe at the ground floor. They will keep only one button. Ground means don't say, sir, underground another floors are there. So parking is there. Don't say that. Okay, only one button. They may give up symbol or no symbol. Always in the lift, you should say them where you want to go. Okay, not to say please come down for lift. You should say to the lift, I want to go up or down. Then it will decide whether it is coming down, whether to stop or not. Means, okay, it is in the stopped condition only. Okay, or it is moving from sixth floor, you take anything. Okay, we used to play by pressing and going by walk. That is anyway it is there. Okay, leave this. This is a general question, but it is related to our state machines. Okay, this is how you need to design. Okay, as a designer, as an engineer, you should think if this is pressed, whether I can save some energy. That single button can save how much energy and time. You just think of it. Okay, so come back to this question. Okay, any button you press, it will come. Okay, because it is a trust generally. Okay, but if it is moving, then it will decide. Lift comes for any case. For example, even it is in the 4th floor, you are in the 3rd, you want to go 5. You pressed down, na? See here, what is the problem? It is a trust. You press down or up, it will come okay. After you press down, you want to go 5th floor, na? After you press down, some fellow here at the 2nd floor has pressed down only. He want to go to ground floor. Then what happens? You boarded into the lift, then you want to go to 5th floor, but because 2nd is pressed, it will go down and stop at 2nd also. Okay, that's why where you want to go, you should press that. Yeah, it will waste your time, and it is carrying you, instead of 2 floors, it is carrying you 8 floors. Okay, which I didn't remember, but I know this logic from childhood. Playing is common anyway. Okay, let's come here. Let's take randomly here. So this is my problem, sir. What is this problem? This is, suppose, listen here. This is given. It is given as a problem. Okay, don't ask me what is the meaning of this figure. I will explain how to understand this figure. That is my job. Don't worry. But this figure, how it comes, it is randomly. Okay, according to my mood, I draw this figure. Okay, there is no logic for this figure. First, okay, given Mealy. What is this spelling of the name? Yeah, Mealy state. इसका नाम क्या? What is its name? State transition. Okay, not full meals. Meal S is meal Y. Okay, state transition diagram. What is the name of this? Because they are good inversions. Okay, still in so many applications they are used. Okay, so in Mealy and more. So this is the Mealy state diagram given. Okay, just for example, randomly taken. Never to please don't ask me what is the meaning of this figure. Okay, because earlier also so many students asked me earlier after explaining this, sir, how this figure came. That's why I'm cautious, little cautious, and telling you that priorly. Now I will tell you how to understand a figure given to you. Figure is already given by examiner. Problem is given, how to draw figure also I will explain, no doubt in it. Okay, first figure is given by examiner. How to understand this? This is the input, this is the output, and this is the node. This junction point is called state. Sir, how to read this? Very simple. Listen carefully. S naught is a state. You are in that particular state. If the input is 0, according to this figure, not every time, according to this figure, if input is 0, you go back. This fellow will go back to S naught only. You are in the school. School bell is ring. No, I stay at school only. Okay, like it is in one state, it is a 0. Okay, if input is 0, output also 0, it will do same thing. Now, if input is 1, input is 1. One minute. If input is 1 here, this fellow will go to home, S1, some state called as S1. Okay, some here to here called S1. and he will give you output also 1. Similarly, S1 is a reverse fellow. If input is 0, he goes to S2. If input is 1, he stays at S1 only. In the first case, is output 1, second case, output 0. There is no logic for output 1 and 0. It is randomly taken everything. I am just explaining the meaning of this table, how to read this table. Okay, here also, when S2, he don't mind whether bell is ring or not, whether input is 0 or 1, anytime he will always go to S0. You are sleeping, okay, your morning, alarm ring or not, no problem. Two type of inputs are there, okay. One is cool, one is hot, okay. There are two ways to wake you up. One is cool way, one is throwing water on your face. Any case, you will go to school. Like that, this is some example. For this particular system, it is at state 2. Input can be 0 or 1. Any case, it will go to S0 only. Okay, just everybody understand this figure or not? Any doubt, please ask up to that. If you understand this, then everything is cool. What is your doubt, Ritik? I am again saying, please listen here. Why S1 is going here? Don't ask the time again. And 100. Okay, I already told you a number of times. Again, I am saying, okay. Why S1 is going here? Why S1 is like this? Don't ask that question. That is of no meaning. It is some randomly given figure. I am just explaining you how to understand this figure. How to understand this figure. That is, suppose you are in one X state. It is S1, S2, anything. According to this figure, if 0 is the input, this fellow will go to S2. If 1 is the input, this fellow will go to this arrow, will tell you where to go. Okay. And this will tell you what is your input. If input is 1, this fellow will go to S1. If input is 0, it will go to S2. Output is, in this case, he will give 1. In this case, it will give you 0. Some like one time green LED, one time red LED, one time alarm. Output can be anything. Your job is not to understand 1 mein kya kaam hota hai, 0 mein kya kaam hota hai. That is not your job here. Here, your job is just to understand this figure. If your input is 0, output is not 0 every time. Please understand. Input can be any input, output are not equal every time. Okay, this can be here. There can be this kind of diagram also. This is one kind of diagram. When input is 0, output can be anything. When input is 1, output can be anything. It depends on the examiner mode or the particular problem. Okay, so now ask me any doubt. Remaining people, again, you understand or not? Still no, please ask. Because if you don't know this, you cannot understand the total class for today. Very good. It's raining outside. Yes, Saurav. That is a random figure. That is an example that is given. That all those stories I told, but still I know some people will have doubt. That's why I asked you to clear. So now everybody got clear. Don't never afraid of me, because you know I can help you n number of times. You ask n number of times, I can explain. Very good. What you want to what is your doubt? Clearly ask, Amitabh-ji. Please ask. That's what I am saying. It is not your job why they are going here or how they are going here. Our job is, it is already like this. Understand what it is doing. It's given. You should not ask your examiner, sir, why examiner ko, you should not ask me why you draw line like this, man, why not like this. Okay, Amitabh, you understand again? There is no logic for this figure. What we need to know is, some figure is already given for us. We need to understand the meaning, that's all. Again, ask me, Amitabh, if it is not clear. I am just saying, okay, why 0 is going here, why 1 is going here, don't ask me. That is the first, from first beginning, I am saying the same point, okay? According to question, according to examiner, For 0, this fellow will go to S2. For 1, this fellow will go to S1. For a particular problem, it is like that. It is given as example. It is given like that. I told already. Lucky. Amitabh, it is clear now? No single person should have doubt in this. If you have doubt in this, you're calm ho gaya. Okay, you cannot understand. Okay, Sura, you can do for anything. For your mind search also, you can draw the state diagram. Okay. Simple way, I'm repeating simply, you are in the state, your input data comes. Then you decide what is the next state or what is the output. This input, whatever coming from outside, will tell you whether next state is S0 or S1 or output is 0 or 1. There is no relation between these two and these two that you need to understand. They need not be equal every time. Now please listen one more thing. Input can be any number of bits. Output also can be any number of bits. There is no strict rule input should be 1 bit or output can be 0 or 1 only. No, input can be any number of bits, output can be any number of bits. There is no restriction for us here. Is it okay? इसमें कुछ restriction नहीं है. Any number of bits at the input, any number of bits at the output. No problem. Okay, next. Here, how many number of states are there? 3. So for this design, how many flip-flops required is the same as our counter design, log to the base 2, 3. It should be greater than or equal to 2. You cannot have 1 point something as your flip-flop now, so 2 flip-flops. Okay, so now let's design this. Let us design this. One minute. Now please listen. What we are going to do? Examiner has given you one state diagram like this randomly. Examiner has given one state diagram like this randomly. You want to design or you want to use some flip-flops, D flip-flop, JK flip-flop, any flip-flop of your love. Then and you want to design this. You want to design one circuit which will do this job. Let me upload the slide. Okay, just wait. Wait for some time. All your doubts will get clear. Now, firstly, what is that? How to understand? I mean, how to read any state diagram? You are able to understand. Okay, how to read any random state diagram? You are able to understand. Now, let us see how to design this. Just wait, Aditya. You will get your doubts cleared. So, how to design a circuit to implement this? Let us do it. Let's do it. So, how to design it? Okay, design block diagram will be like this. Okay, you will have one circuit like this. Which contains the state, input logic, sorry. This block diagram will contains one thing. What is that we call output logic? And here you give your input, say name X, and here you will get output, say Z or Y, anything. Okay, and here one more logic is required, that is state input logic. So here you have two flip-flops. Take two flip-flops. Let us draw neatly. Okay. Say this is a D flip-flop. DB, DA, D1, D0. Anything you take. QB, QB bar, QA, QA. Okay. Now you connect this to the feedback. It's not counter, it's a synchronous design. Clock is common is synchronous design. It is not counter. You can take it as a some kind of counter, but our intention is not to design the counter. Okay. So please listen here. This is your QB and QA and so on. This is the, see here. This is the present state. Now understand how we are, this we design it now. Okay, everybody understand? This whole job we will do it. You can take any flip-flop. Again, you will get that doubt. Why D flip-flop, sir? You like it? No. Okay, any flip-flop is okay. We can take any flip-flop. It is your wish. JK flip-flop chahe to JK le lijiye. Okay, it is up to your wish. Nothing wrong. So this is the block diagram of your design. Here two flip-flops came, so I took two flip-flops. Okay, so here based on your input and present state, this circuit will drive the next state. Okay, this is the next state input. You understand this? It is next state input. Present based, see here, simple logic. Your input is there, present is there. Your input will give you the output, present state will give you the next state input. When you apply the clock, this next state will come here. When you apply the clock, this next state will come here. You understand? Here output is asynchronous. Output is not depending on clock. Okay. This is the block diagram of Mealy design. So now we should design this. This is our job. Now what is your job? To design this. Let's design. Okay. Hmm. Actually, output is not depending on clock. It depends on input and this value. Even some input changes, it can change. Just wait, Vasista, it will clear your doubt. Okay, just wait until the completion of the design. After that, if you have the same doubt, ask. I mean, output is indirectly depending, not directly depending. That is, output is not having a restriction. It can change only when clock is there. Even for previous value, new input comes, it will give some kind of new output. Okay, right. So this is the figure now. So let me draw one thing called state diagram. sorry, state table. Let me make state table. Understand this. What is state table, sir? Converting the state diagram, this diagram, transition diagram, into a simple tabular format so that you can understand easily. What is the use of it? Later, when we do some kind of state table reduction, etc., I will explain. Okay, for timing, don't worry about it. So this contains, you are designing this, please understand. According to the design, it contains 3 parts. So first one is present state. You have 3 present states. What are they? S0, S1, S2. For these 3 present states, what is the next state? If x equal to 0 and x equal to 1. What is x, sir? What is x? X is your input and Z is your output. Si is your state. Is the terminology we are following. If x equal to 0, what is your next state? X equal to 1, what is the next state? Similarly, what is the output when x equal to 0 and x equal to 1? Let me draw this figure. Okay, let me fill this table. You only tell me from this figure, everybody carefully tell me how to make this table. When x is 0, this is your x and this is your z. Okay, so when x is 0, according to this figure, for S0, when x is 0, what is the next state? Everybody, S0 only. What is the output? 0. Similarly, when x is 1, it will go to S1. Output? Next. Similarly, for S1, when input is 0, he will go to S2 with output 1. When input is 1, he will go to S1 only with output 0. Again, for S2, if input is 0, he go to S0, okay, with output 0. When input is 1, then also he will go to S0 with output 1. This is another way to represent this. This is one way to represent a problem. This is another way to represent the problem. What is the name of it? State table. 0, 0, 0, 0. Okay. Let me not confuse you. Okay. For S1, okay. If input is 0, Krishna, you tell me, remaining people don't comment. You tell me, you are in S1. So assume you are standing here. Your input is 0. What is the next state? You are in the state 1. Your input is 0. Where you go according to this figure? Krishna, tell me. S2. That's what I read. Why it is going to S2, sir? According to figure. Why this figure is like this? No one knows. It is a random figure. Okay, next. Similarly, according to S1, you told S2. Okay, if 0 comes, it goes to S2. What is the output it is giving? What is the output it is giving? That's all. I asked only Krishna. Okay. Next. Similarly, when you are in S1 only, if input is 1, where he will go? As Krishna, tell me. Where he will go? S1 only. Output? That's what I made the table side that only. So many people are still concentrating why this figure is like this. Why these people are going here, not here. Okay, don't worry about it. It is a random figure. Again, I am saying a number of times. It is randomly taken. There is no logic for why it is going here or here. Okay, got it? Anyone having doubt, ask me. Otherwise, we move further. Once I explain, it is the same way to solve anything. Very good, very good, very good. Now let me do small part here. State assignment. What is state assignment, sir? I took two flip-flops, na QB, QA. These two bits will tell you represent your state. Here, who is representing your states? QB, QA. QB, QA will represent your state. So I should assign, as a designer, I should assign QB, QA combinations, that is 0, 0, 0, 1, 1, 0, 1, 1 to one particular state. If it is a 0, 0, give it to S0. 0, 1, name it as S1. A 1, 0, name it as S2. 1, 1, here only 3 are there, don't use it. Here, there is no strict rule you should use this order only. Take any order. Okay, let me complete then ask. Okay, take any order. Okay, so you should have three different ways to represent S, not S1, S2. You can represent 0, 0, 1, 1, 1, 0 as S, not S1, S2. It is not a sequence, it's what we call counter. It need not count in a sequence. Okay, you represent accordingly, but design should be made accordingly. You represent according to your wish. 0, 0 you represent for S1, 1, 1 for S2, 1, 0 for S0. No problem. It is your choice only. You have four different states in that pick three and assign them to your S0, S1, S0. Is it you understand? I am saying here S0. How to show that S0 in this figure? How to show that S0 in this figure? By making it 0, 0. How to show S1? By sending here 0, 1. How to get 1, 0? By sending here 1, 0. That's all. So now any doubt, please ask. Otherwise, we move to the next one. Okay. So now we have not designed anything, Amitabh. We are yet to design. Just wait. You are just making the table and further from the flip flops. Okay, you are okay. This is just a block diagram. Okay, we are yet to begin. Don't worry about it. Amitabh, okay, leave it. Now see here. Now, lastly, let's start the design after doing this. Okay, listen. Now, please listen carefully. Now we are going to the design part. I think the space will not be sufficient. Okay. The next part of your design is input output table. Stop that. Listen here. Listen here. Present state like similar to counter design. Here also you are doing the design. Present state. What is your next state required? And what are the inputs to be applied? Whenever input comes, what is the meaning of it? Input means, what is the meaning of it? No, not characteristic. Input means always excitation table only. So your present state contains two flip-flops, QB, QA, and also X. Everybody, listen. QB, QA, X is your present state. What does it mean? You have presently some state and input. What will be the next state? Means the next QB, QA, and Z. What is Z here? Output. What is X here? Input. And what are the necessary inputs you should give here? This is the table you should complete. You in the sense we. Okay. So here you take all possible combinations of these three variables. That is 0, 0, 0 to all ones. Okay. Now already you know whenever these two are 0 zeros, we have given it as a name as naught. For this we have given name as 1. For this we have given name as 2. For this we have not given any name. Leave it. Show this. Don't care. Up to this, okay. So 0, 0 is S naught. And see, what is the meaning? You are at S naught. Your input can be 0, 1. You are at S1. Your input can be 0, 1. You are at S2. Your input can be 0, 1. You are not. You are at 1, 1. Input can be 0, 1. Now, what is the next state according to this? Tell me. Just tell me, you are in the S naught. If input is 0, what is your next state? No, you should tell me 0, 0, 0, 0, 0, 1 like that. What is the next state? It is 0, 0, output 0. Here Z means output. S naught with output 0. That is 0, 0, output 0. Very good. Next. Similarly, here what is the next state? Everybody. If it is 1, input is 1, you should go to S1 with output 1. Okay. Next. Listen here. Similarly. For this S2 and 1. So I'm just filling this table based on that. S2 with output 1 according to the previous table. Okay. Otherwise, it is S1 with output 0. That is, if input is 1, it is S1 with 0. Next, for 1, 0. Both the cases S0, 0. Both the cases S0, 0. So it will be both the cases S0 and 0. And these are no problem. A can be anything. Okay, you know already lockout. Here also that is possible. Okay. So we may take it any user state. Same stories. Similar to counter only. Next. Now, what are the inputs to be given? What are the inputs to be given? Inputs means what? Excitation table of D flip-flop. It is very simple. Excitation table of D flip-flop is same Qn plus 1 equal to what? D. Here, very good. Whatever you want in the next state, that should be given as the input. So take one quad, another, sorry, K-map, another K-map. So you should solve this. Your design is ready. Take your design and go. So one vendor came to you, he has given some problem. After that, you have converted into state diagram. You made the design like this. Your job is done. Okay, till now I have not given how to draw the state diagram. I will explain that also, don't worry. So charge is up to your demand. QB, QA and X. QB, QA and X. Here three people are deciding QB, QA and X. They are deciding your Z and DB and DA. What are the inputs you should go for DB, DA and what is the output you should get. Okay. So now what is that? Fill this first. What is that? 0, 110, 00, double cross. Next 0010, 00, double cross. Next 01, 01. Power may go, but no problem. We have some backup. Very big range. क्या हुआ 01 DB DA 01 01 00 double cross 00 10 00 cross key map में same only na. This is your input present state QB QA X. What is the problem? Okay, no problem. Understood. Okay, fine. So it is a QB. QB QA X. QB QX. QB QAX 0001 1110 01 0001 1110 0001 1110. Okay. Tomorrow doubt session, please don't miss. We do some important problems like monostable multivibrator, frequency measurement using counter, etc. We'll do it. Okay, please don't miss the class. So okay, आपका job हो गया. This is one thing, and this is a simple single. This is also same, and here this is the pair. Now, what is your Z? It is QB bar QA bar X plus QB X bar. Here QA X bar. Here QB bar X. You have done. You are done with the problem. Now you should draw the figure. So now Z is output. What happened? Z is done now. This is your Z. Actually, Z is this is what you want. Z is what you want according to this. Z में कुछ problem है क्या? QB bar, QA bar, X, Q, A X bar. Okay. Yes. Okay. QA X bar. Excitation table is same as your. What happened, Rahul? You should not ask me this after completion of the class. You should revise the things. Qn plus 1 is D. Whatever you have here, same comes here. Okay, I already told you its importance. You should remember compulsory all flip-flops, excitation table. Whatever you want in the next state, present state, next state, what are the inputs? Input same as next state. You just copy this box and paste it here. 1 minute, Rahul. You take this box, apply Control C, apply Control V. Okay. I already told, don't care, sir. There is a chance of lockout. They may repeat, counter may repeat, or state diagram may repeat. That can happen. Suppose you take this, listen. It is S2. According to this table, S2, your input is 0. That is S2 with input is 0. Okay. What is the next state? S0. That's why I took 0. And what is the output? 0. That's why I took 0. Similarly, you are in S1. Your input is 0. Go to S2. S1 with input 0. Go to S2. What is the output? 1. That's why it is 1. It's from this table. Clear one? Very good. So present to next. Everybody clear? This is just a copy of this only. We gave names, that's all. Right. Now let's design it. So take one box. One minute. We can do it. Okay, let's design this. I'm just keeping that figure so that you will understand later properly. I mean, now it has two inputs. What are they? X is the input, Z is the output. Okay, next. You have two flip flops. Amitabh, concentrate now. Deadlock हो गया. I could have copy paste this one. The problem could be more easy. Anyway, let's learn it here. This is only Mealy. Murray is different, I told na. I'll explain that also, don't worry. Yes, definitely lucky. Okay, done. So now this is your X, Z, D flip flop, clock, A, QB, QA, QA bar. This is the flip flop. Okay. So what you get is QB, QB bar, QA, QA bar. Okay, all of them are available. Just design this simple circuit. What is that? QB bar, QA bar, X, QB bar is available now. QA bar, X. Take one AND gate. Actually, you should take from here to here some connections. I don't suggest that. QB bar, QA bar, X connections like you should connect it. That will take so much. I mean, it will show you complexly. Why to do that? Simply write and writing it. Okay. So next QA X bar. QA X bar means you should take inverter because X is available. X bar is not directly available. And now take one OR gate. This will finish Z. What about DB? DB is QA X bar. DB is QA X bar. Anyway, it is there. I am using it. Next, DA is QB bar X. DA is QB bar X. So take one gate and finish it. हो गया आपका design. Now ask all your doubts. So 1 minute, 1 minute, 1 minute. Let's go back to the basic. It is satisfied or not? Your input and the next state are designing your output combinational logic. Okay, your input state register will tell you what is the next state. Okay, we may be designed like this. Okay, it depends. Here, your output is firstly listen here. 1 minute, let me complete. Output depending on these values only. They may come because of clock, but even clock is not there. Some previous values may there. Now X changed. Output can change. May give right or wrong, but output can disturb by X. But here X changes. Output will not be disturbed until you apply the clock. For the next state, this will give you next state. This is the output. Okay, this is the present state. You may see both are same na sir. I mean, when you apply the clock, this will come. Okay, these are the next state inputs. That's all. So reading this, it is I think every point I'm writing here, Amitabh. If you are comfortable with this, then you read this itself. I mean, in this you are having more compared to that PDF. Every single theory point also I will type or I will write definitely. That such that after the class, if you download the PDF also, it is sufficient. So now ask me any doubts. We have made the design. X is the input, then input will change. What is the question, Rohit? X is your input. When X changes, your output changes. Yes. Output depend on present state and input. Correct, Aditya? But false can occur. So if by chance some disturbance has occurred, that disturbance can affect your output. Hazards can occur. Correct, Aditya. So it is the logic for output, and this is the logic for your input. ये क्या? What is this, Aditya? Sub hai. We should see that, sir. Abhijit, tell me, this circuit is same as this equation. We have these three equations now. Okay, this is for dB and dA. So these three equations are taken and we have implemented QB QA from the flip flops, QB bar QA bar, and X is the input, or Y is Z is the output. So you connected accordingly. Any other doubt? Please ask. So for the random figure like this is how you design the state machine. Question will come after 1 hour. There is a lot of theory to learn first. Time consuming क्या इसमें? You want only question and answers, then 1 mark 5 minutes में हो जाएंगे. State register means this part, Abhijit. You see here, you have here 1 0. This 1 0 will come here. Okay. 1 0 means what? S2. Okay, you are in 1 0. Okay. QB is 1, QA is 0. So see here. Where is your QB? 1. QB bar is 0. QA bar is 1. QA is 0. So let's apply X equal to 1. When you apply X equal to 1, what happens? 1 bar is 0. 0 into 0 is 0. Some end operation of 0 bar is 1. 1 bar is 0. This is 0 and you get output equal to 0. Okay. And also here you get 0. QB bar is 0 and this is X is 0. 0 0 will give you 0. So the next state after applying the clock, they will change to 0 0. Okay. So it is doing that job or not? Just take this figure, apply any state, apply the input, check how it is happening. Everything you can play. Abhijit clear? Aditya clear? Everybody understand? It is in IES also. One topic is there. I forget that subject name. In the I think design of some LSA, in that some extra subject, new subjects, this topic is there. What is your doubt, Agni? Every year they are giving questions. That's why I am stressing little more. Only questions if you want to solve, just 1 hour we can do all the questions and you may feel that you understand. But any twist they give, you should understand the background behind. In state diagram, okay, please listen. Who is that? Abhinay? I just not told na. You are in S0. Your input is 0, output obviously comes. Output is not depending on clock. The same way na. S0 में है 0 apply किया output 0 same. You are in S0 already. You are in S0. You apply input, you get the output. Your output depends on present already existing and X. It does not depend on clock. Output is independent of clock. Aditya doubt is also cleared now. I made 1-0 here. You are in S2. Okay, when you apply some input, where it is going, I showed. Abhinay, clear? This will tell you. Please see, this is not depending on clock directly. Once you get this, your input comes, it will come. Your input fellow comes, it will come immediately. After that, it changes, again it changes. So it can change by two methods, by changing this or by changing this. Okay? Any doubt, please ask. Aditya, your doubt is cleared. Abhinay, your doubt is cleared or not? Please ask me. Yes, indirectly depending on clock. I wrote that already. I don't know. Maybe your health is not good. Output depends on present state only. What I wrote here, input cannot affect the output directly. Input affects the state, state affects the output. I write this here already. Okay. So if input is equal to 1, so output is 1. But input equal to 1, why output is 1, man? Input is 1. Okay. No clock. What is your problem? I didn't understand. No clock is there. Okay. By that time, already some state is there. Na? Listen, Abhinay. Clock not there. No problem. You are in some state already. Say, take any of this. Say, for example, you are in S1. That is, you have 1-0 here. Already you are here. Clock is not given. No problem. Your input is applied. So, input is 0, for example. So, 1, 0, 0. It will give the next output. For 1, 0, 0, according to this table, what is your output? 0. That will come here. No doubt in it. 100, what is 1 minute? Not 100. You are in, yeah, 100. What is the output? That will definitely come. Only, okay, when you give the input, immediately this changes. But due to this, whatever comes here, that will change when you apply clock only. That's what I said. Your output is asynchronous here. Output is asynchronous. This is synchronous. Okay. This is a present state, not next state. S0 is the present state. Present state and input will decide your output. Present state and input will decide the output. Okay. Even it don't goes here, before that itself it will change. That's what I'm saying. Even it is not traveling from here, before that itself this fellow will change. I didn't show this in the state now. That's why it is showed in between. When the process starts, first the output will change, then the state will change. Okay, very good. Asynchronous. Now, whatever the doubts you got it, that I mean, the difficulties we faced here, that we overcome with the help of Moore design. But that can also have some disadvantage. We see both of them comparatively also. Okay, let's move. Next, our second trend, Moore state machine. Moore state machine. Okay, the Moore state machine, they don't give in the question. You can identify it. I will show you how to identify. Let me complete this more. Always don't learn for exam. First understand the concepts, then you can understand. Okay, if examiner what given how to tackle it, don't worry about it. Just wait for something. Shall I pass deep? Now listen here. Moore state machine. If if a Mealy state machine contains m output bits and n states, okay, then corresponding Moore design contains maximum 2 power m into n number of states. This is not compulsory. This is maximum number of states. So here number of states will increase. Here number of states will increase. How they will increase? Very simple rule. Listen here. Here for example state 0 is there. Your output can be 0 or output can be what? 1. Like that every state has two possibilities. Na? When you are in S1 while traveling it has become 1. Okay, S1 may your output can be 1. Or your S1 can have output can be 0 also. Two possibilities are there according to your output. So now I will make it split into two parts. How? This state can be split into two parts, two different states. Then S10 means it is a state 1 with output 0. I will make it into S11, that is state 1 with output 1, such that there is no, during the transition, this will not change. After reaching only, it will change. Let me show you. Okay, you understand the theme of the Moore design? To have m number of output bits, the corresponding Moore design will contain 2 power m into state maximum. Okay, that is less than or equal to 2 power m into n. So let's take the same problem again. S0, S1, S2. Same figure I am taking. This is the figure. This is Mealy. I want to convert this into Moore. What is number of bits for output here? 1 bit only. Number of states 3. So maximum states in Moore is equal to maximum states is equal to 2 power 1 into 3. It is 6. So maximum is 6. It can be less also. So what are the 6 states, sir? See here. I follow this notation. Sij. What is Sij? It is a state I with output j. What is the meaning of state ij? What is the meaning of Sij? Please listen. After listening this theory, all problems you can solve like anything. Okay, just wait until the completion of the topic. 1-2 minutes may all answers are. So state I with the output j, state I with the output equal to j. So this is the meaning. So now let's have every state split it into two states. S0 is there, make it S0 0 0, S0 1, S0 S1 0, S1 ka another friend 1, S2 0, S2 ka another friend 1. So now listen, you are in the S0. with output 0. Now careful understanding is important. Please carefully concentrate here. Listen here. You are in this state. You are in this state. If 0 comes, you are in S0. Assume output is also 0. Okay, if 0 comes, you go back to S0 only with output 0. Okay, so in S0, if S0 0 0, that is S0 0, if 0 comes, where you are going? S0 0 or S0 1? Comment. Here you should not write output line. Don't write output. Forget about output. Indirectly here, this bit will tell you output. I mean, this notation will give you output. Only you should write like this. Now, next, you are in the S0 with output 0. If 1 comes, where he will go? 1 comes, he is moving to S1 with giving output 1. So, where he will go? S11 or S10? Oh yeah, your job is done. Your job is done. Those who have doubt, I will explain that. Just wait. See here, you are in S0. Two possibilities are there. You are S00. Two possibilities are there. Your input is 0. Your output is 0, and you are going to S0 only. Where input is 0, you are going to S0 with output 0. S0 with output 0. If your input is 1, you are going to S1. You are going to S1 only. It can be this one or this one. In that, output is how much? 1. So that's why it is S1. Sora, is it clear now? Very good. Now, you are in S11. That is, you are in the state 1 with output 1. So already here से here तक आया. Here तक आने के बाद you are in S1 with output 1. Here also every statement two possibilities are there. Your input can be 0, input can be 1. This is the input bit. Please understand. Your input can be 0 or 1. Two possibilities are there. Now please listen here. Tell me, if input is 0, where he will go? If input is 0, where he will go? Jan say, input 0, where he is going is S2. What is the output he get is 1. That's why S2 1. Input 0, he will go to S2 1. If input 1, where he will go? Where he will go? He will go to S1 only, but now output is 0. Input is 1, he will go to S1 only with output 0. Wait. Now again, two new states came for us. We should analyze every state with two possibilities, input 0 and input 1. Here this is input only. These lines are saying input. Here no output specification, no output. Okay, just wait for some time. Up to that, no output. Okay, so now see here. Come here, S10. What does it mean? You are in the state 1 with output 0. You are in the state 1 with output 0. Again, you have two choices. You came to state 1 with output 0. Again, if again 1 comes, what is the output? Just don't comment until the completion of the figure. Concentrate, please concentrate with a positive meaning of understanding. Okay, so just wait. You are in the state 1 with output 0. If 1 comes, what is the next? What is the output you get? 0, and you go back to S1 only. So can I say like this? Yes, very good. Next, you are in the state 1 with output 0. If 0 occurs, where he is going? He will go to S21. Lastly, S21. S21 means you came here, output is 1. Now, if 0 occurs or 1 occurs, both the cases you are moving to S0, giving the output 0. 1 minute. Okay. Okay, आपका problem. Now wait. Okay, until the completion, don't worry about it. Now these two figures are not touched. Why they don't touch anyone? They are least liked by anyone or what? Why they are not touched? Comment please. Why they are untouched? No lockout, no lockdown, lucky. It is not, don't care. Wait. Not unused. Why they are unused is my question here. They are untouched means unused only. Why they are unused? That is the question. Yes, Chutki, correct answer. Okay. Why they are not occurring? According to this figure, how to understand that? S01. S01 means you are in the state 0 with output 1. You come, listen carefully. You are coming to S0 by 3 paths. Incoming paths, kitna 3 paths hai. You are coming to this. In all the cases, what is the output? So whenever you come to S0, always, okay, raste mein output kya hua? 0 hua. According to this figure. So this fellow will not occur. Similarly, for S2 also. S2 का एक ही incoming path है. What is that? S2 can be reached by this. There is no other route. Here bus route, train route, air route, 3 routes are there. Here only one route to reach S2. In that, output is how much? 1. That's why S2 1 is there, but S2 0 is not there. Now come here. But for S1 is good boy. He is having both the cases. When you come like this to S1, he give 1. When you come like this, he gives 0. Okay, so when you are in S1, when you can come like this or you can come like this. So though possibilities are, S1 can be reached when you are reaching whatever may be the path. Output can be 1, output can be 0. That's why S1 0 is there, S1 1 is there, but not S0 1 and S2 0. Initially is S0 not is by default. Okay, the examiner will give you that initial state. Okay, nothing specified. We assume this as the initial state. You start here from anywhere, you will get the same figure, no problem. One route is there, output can be anything. See here, Ganguly. You came in the middle, I think. Please see. This is S00, this is S21. Here 0 is possible, 1 is possible. It depends on figure. From any point, nothing wrong. You start from any point of your wish. We assume here all possibilities. Here we assume all the possibilities. After drawing, I realized this will not happen. Remaining people, please ask me. Why? S212, S00. Why not S20? S212, you tell me here. From here, you can go to 2 ways. Outgoing, I am saying. From here to, you are going to outgoing. Both the cases, you are going to S0 or anywhere. Yes, Shutki, very good. Okay, Amitabh. Then you should answer me why it is going to S0 not S20. Very good. You ask your doubt, please, Aditya. Please see, these are not outputs. These are inputs, man. Who is that? Krishna. This line may whatever you have, these are inputs only. We can start from anywhere happily. You start from here also. Okay. Anywhere you start, same figure will come. I'm again saying, please see, these lines are outputs, not outputs. These are input lines. If you start from S01, then you go figure. Okay, S01 is not there, so you don't start. You may assume S01 and come here now. We should realize that here now. I said S00 means I started here because S00 is there. Okay, if I say S01, I will come here and check where is S01. No, na, S0 is there, but output 1 is not there for S0. So this will not occur. Yes. Vasishtha, please ask your doubt. S11 to S10 output 0. Yeah, S11. Okay. To S10 output is 0 only. What is the problem in that? We take the same now. Output is 0. These are not outputs, man. Everybody, these are inputs. I already wrote that here. These ones and zeros are what? Inputs. I have not specified output everywhere, anywhere. Please ask the specific doubt. What is your doubt, Rohit? I can explain. Vasishtha, is it clear? Now, few minutes, wait. Wait. Amitabh, if you, where is your doubt? We don't choose incoming. We see these lines and say, from here to where you are going. The same we do here. Okay. So wait, listen here. Just wait for some time, everybody. Now you can convert this figure into this name. A. Don't worry. I am there. Okay. I will again explain if required. Don't worry about it. Just wait. Okay. I am converting this figure into this figure. Simple way is A, B, C, D. Names लिखा. Okay. इसका names change किया. इसका name क्या? नया name A, B, C, D. Okay. A का output तो fix किया मैंने 0. So whenever I am in, okay. Whenever I am in A, your output is always 0. Whenever I am B, 1. Whenever I am C, output is 0. Whenever I am in D, your output is 1. These are fixed. That is this node. Whenever you reach here, output is always 0. Whenever you reach here, output is always 1. This is fixed. Okay. Now, complete the figure. Listen. Now, listen here. This is the same or not? These are the what we call Moore state transition diagrams. Okay. Now understand this figure. When you are in A, output is already fixed. Here you need not talk about output at all now. If input is 0, you come back to A only. When you are in A, if input is 1, you go to B. If input is 0, you go to D. Input is 1, you go to C. This is how you should understand this figure. Okay. I ask you to hold your doubts until the completion, Saurav. Okay. Please don't comment in between. Let me complete the explanation first. Okay. Other peoples will be deviated. That is the reason. I ask you, okay, whenever after completion of this, again, I will ask you for your doubts. Just wait for that. So A, B, C, D are my state diagrams. Now everybody, how many states are there? Number of states equal to 4. How many flip-flops are required? Log to the base 2 4, which is 2 flip-flops. Okay, 2 flip-flops are required. Now, one simple design. Complete the design like melee. Okay, for example, your S1, S0 can be 0, sorry. Get two flip-flops. What are they? QB, QA can be 0, 0, 0, 1, 1, 0, 1, 1. Give the names. What are they? S0, S1. Sorry, what are the new names? A, B, C, D. Now, tell me what is the output for A, B, C, D? Output is 0, 1, 0, 1. So what is the output expression? Output Z. Okay, what is your Z? It is 0, 1, 0, 1. Just directly depends on this only. What is that? It is 1 for two cases. QB, QA bar. So QB bar, QA plus QB, QA, which will give you QA. This is synchronous. You understand now? Your output is synchronous. It purely depends on the state for the same problem. Okay, and design is also simpler here compared to that. Maybe number of states increased. Luckily here 3, here 4. Both the cases number of flip-flops same. Okay, but suppose if it is 5, you may need extra flip-flop. Okay, so flip-flops wise, it may require more flip-flops. Remaining part, what is that? It is simpler design. Okay, it's output logic. Earlier, you see how much big logic is there, output expression. What is output expression? QB bar, QA bar X plus QA X bar. But here, what is your output? It is simply QA. Tomorrow, I will give you the differences. Don't worry about it. Output only depends on the state, but state indirectly depends on your input. Okay, so here output logic you need not design it, only state logic you should design. Try that. Okay, now come back for this figure. Some few people are having doubts. Let me clear them. Okay, so let me go step by step. Just wait. Aditya, you have explained. Okay, fine. Okay. So now any doubt, ask me. Output only depends on the present state. All understood, but not difference. What is difference, man? Difference between Mealy and Moore. You see the difference between this figure and this figure. Here you are in the transition. Okay, your output is changed in the transition itself. But here, until you reach the state, your output is not changing. Until you come here, your output will not change. Figure itself showing differently. You understand or not? Here, while coming itself, when you give the input, first output changes, then state changes. Here, when input comes, you go to that state. That state will tell you what is the output. So here, input changes, clock is not applied. Output won't change here. Input cannot affect the output directly. So, for example, here, see, if X changes, every time X changes, output can change or something can happen. But here, not like that. Output purely independent of X. Purely in the sense, expression-wise. Expression-wise, independent of X. If X changes, that X will affect this one. Once this changes, then only output changes. That is, it is depending on clock here. That is synchronous. Your output is synchronous in the Moore design. Okay, now Rohit, you are there? For those who are having doubt in understanding this, I mean what we call Mealy to Moore conversion, let me explain again. Yes, Aditya. Okay, this S0 value and this input value immediately changes the output. Here immediately this changes the output. This S0 value, input value immediately changes the output. Then once clock is applied, you will come here. Now see here. Okay, just wait, Sushil. Here itself it is there. Okay, remaining people don't comment anything until the completion, then I will ask you. Okay, so see here, you are in this state. Okay, when input is 0, output can be anything. Input is 1, output can be anything. Okay, so here what does it mean? What is the meaning of this line? You are in the state 0, assume initially output is also 0. Okay, take this loop into consideration, or any of these lines into consideration. Start with S00, or start with any of these lines into consideration. What is that? S11 or S10, or you can also start with S21. These are the starting states you can start. What are they? Incoming arrows. S0 with 0, or its incoming arrow S21, or start from any point S11 or S10. You start any point of your wish. So I started with S00. Now please understand, S00 का meaning क्या? It is state 0 with output 0. So if your output is having 1 bit, 2 possibilities are there. If your output are having m is equal to 1 bit, 2 possibilities. So 2 power 1, it can be 0 or 1, 2 power 1 possibilities into total 3 states. So every 3 states are having 2 possibilities. Suppose if you are having n number of states, your output bit is 2 bits. It can be 0, 0, 0, 1, 1, 0, 1, 1. In that case, your output can have, each state can have how many combinations? 4 combinations. Here output is a single bit, but output can be 2 bits. In that case, each state will have 4 combinations. Then 2 power 2. Like that, if your Mealy design is having n states with m output bits, maximum possibility is 2 power m into n. Sushil, now it is clear? Okay, leave it. Now come to how to draw this figure. How to draw this figure. How to draw this figure from this figure. Okay, so now see here. You just have 3 states. Take all the 3 states into 2 possibilities: 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. 6 possibilities ले लिया. You have taken the 6 possibilities. Now start from any of the used states, any of the available valid state. So go for here S0, 0, S0, 0, S0 with output 0. Okay. Now your input can be 2 things. You only tell me input. Rohit, please tell me. Input can be 2 things. It can be 0 or 1. So when you are in S00, your input can be 2 things. What are they? It can be 0, it can be 1. Okay. Now according to the figure, if input is 0, is going to the same state with 0. So I should say S00 only. If input is 1, he is going to S1 with 1. So he should go to the state of, what is that? S1. And what is the output? 1. You understand this or not? Tell me, Rohit. Everybody, you understand this single figure, small figure? Yes or no? Anyone having doubt in this figure, ask me. Very good. You understand, then every job is simple now. Now come here. Come here. Every statement 2 possibilities check karna chahiye. What are those 2 possibilities? If input is 0, if input is 1. Again, now see here. Now see here. Don't forget about the total figure. Don't worry about it. You take this state. What is that? You came to S11. You are in S1 with output 1 already here. S11 or S10, whatever may be, S1 same. That is, its outputs will be same. Don't confuse. Okay. S11 and S10 both ka 1 case mein and 0 case mein, they will go to same location. Okay. They are not different states. We splitted. Their incoming may be different. Outgoing will be same. Is it clear? You just listen. Now listen here. You are in S11. You are in the state 1 with output 1. Okay. You are in the state 1 with output 1. Now, two possibilities are there. Your input can be 0, your input can be 1. Very good, Nishita, you can leave. Those who understand, you can leave. I don't discuss anything else. For them, good night. Okay. So, in 2 minutes, those who don't understand can also leave by understanding. Okay. So, now see here, just few minutes. S11, S11, you are there. Okay. Now, everybody tell me two possibilities are there. Now, input can be 0, input can be 1. Input can be 0, input can be 1. So, if input is 0, you go to S2 and give 1. Gift क्या ले लिया क्या दिया 1. Go to S2, give him 1. Okay, if input is 1, go to S1 and give him 0. So in this, go to S2 or S1 0. Like that, fill the remaining two states also. That's all. Anyone having doubts still, please ask. Rohit, is it clear now for you? Yes, Abhinay. Yes, Muru is synchronous. Thank you. Thank you. Thank you very much. Good night, all. So, this is the basic part. One more is this, what we call sequence detector. What happened, Lucky? See this. It is the final for Melee. Muri, we have not designed. I have given as homework for you. Thank you very much, all. Good night. So just revise this tomorrow anyway. Doubt session, you can ask me again. Just take the screenshot and ask me any kind of doubts you are having. So sequence detector, yes, I will discuss it. Sequence detector, I will discuss. Then all previous problems we will do it. You can see after our discussion, any question on it on your own within 1 minute you will be able to do it. Synchronous not up, Abhinay. You just go to the lecture. See there is a line. I have told how to do down also. And for synchronous, whether it is up or down, design is the same process. I told you how to design any random counter, not only up down. If you are able to do 0, 3, 1, 2, what does it mean? You are able to do 0, 3, 2, 1 also. Now, process is same. Present state, input, and next state. Any random means random can contain up and down also. You want some questions as a homework or practice? I can upload. Process, synchronous design process is same for any counter, whether it is up or down or random, present state, next state, inputs. That's all. Okay, let me give you a few questions. Then we can end the class. Yes. Tomorrow we do these questions. Thank you. Good night. Tomorrow we can enjoy the pool. Thank you. Good night. Try all these questions.